So I've already taken a look and overview at series circuits, so now let's go into parallel circuits and see how they're different. So if I have this simple parallel circuit with a potential of my battery, VB, and two resistors in parallel, R1 and R2. First, I want to find my total current. And as we said in class, to combine these resistors, I have to do 1 over R equivalent is equal to 1 over R1 plus 1 over R2. So to get my equivalent resistance, whenever I do this, I can't stop there. I have to take the inverse because this is over 1 over my equivalent resistance. So, using Ohm's law, voltage of my battery is equal to my total current times my equivalent resistance, which if I just substitute this in, is 1 over R1 plus 1 over R2 to the negative 1. And if I solve for that current, that tells me the total current coming in right here. Now what's interesting is, when I get to this point right here, the current has two options. It can either go this way, or it can go this way. So what happens is I get two different currents, I1 and I2. Now a rule that we have to follow is my total current is equal to the sum of these two currents. Basically what goes in to this area right here has to come out. So these I1 and I2 added together must equal the total current. Now the question becomes, how do I solve for those two currents? It's actually very simple if we know one thing. This circuit has two loops embedded within it. So I can either go the blue path or the green path. Now if I go through the blue path, let's use my additive voltage. I start with my battery voltage. If I go along the blue, there's only one resistor I go through, and that's resistor 1. So I know that my battery voltage plus whatever drop goes through 1 has to equal 0, because I must get to a potential of 0 by the end. And now if I go through the green, I don't go through R1, but I go through R2. So now delta V2 plus delta VB equals 0. And if I know these two are true, that must mean my potential drop on R1 must equal my potential drop of R2. And so that's extremely useful, because now I know that delta V1 is just I1 times R1. Delta V2 is just I2 times R2. And if both of these potentials are equal to each other, what do these equations say they're equal to? They're both equal to my potential drop across the battery. And so really, both of these are equal to whatever potential my battery has. And so there, I can easily solve for those two currents and pretty much have the answer to every variable I could have on this circuit. So let's do a simple example. I have a 12-volt battery connected to two resistors in parallel, 2 ohms and 5 ohms. And I want to solve for the total current, this total current, and I want to solve for this current, I1, and this current, I2. So how do we do that? Well, first I need to combine these two resistors that are in parallel. And so I know that my 1 over equivalent resistance is equal to 1 over 2 plus 1 over 5. And I know I can find least common denominator, which is 10. So 1 over my equivalent resistance is equal to 5 tenths plus 2 tenths, which is 7 tenths, but that's equal to 1 over my equivalent resistance. So my equivalent resistance here is 10 over 7, which is also equal to 1.43 ohms. So now that I have my equivalent resistance, I want to use Ohm's law. So potential drop across my battery is equal to current times equivalent resistance. So 12 is equal to I times 1.43. So if I solve for I get my total current is 8.39 amps. And I'm actually going to round that to 8.4. So now I need to solve for I1 and I2. Now I know from what I just talked about that the voltage drop across the 2 and the 5 are equal, and they're equal to the battery. So if I have 12 volts is equal to I1 times 2 ohms, then I1 is equal to 6 amps. So I know I1 is equal to 6 amps. Now I can do the same thing for I2. 12 is equal to I2 times 5. So I2 is equal to 2.4 amps. And to check it, I should say I2 plus I1 is equal to I. And so I total is 8.4, I1 is 6, and I2 is 2.4. And yes, 2.4 plus 6 is equal to 8.4. And that's all I can solve for on a parallel circuit.